All right, let's get started. Hi, everyone. I hope you guys are enjoying the event. I hope you've had a chance to try out the racing or the go-karts, a lot of fun stuff out there. But I'm here today to talk to you guys about building apps in Web3. What goes into building a front-end application? To get started with that, it's really not that much different from Web 2. Web 1 really was just a read-only templating, websites like the old Google, MSN, Yahoo. Web 2 came along, and all of a sudden you have these interactive, rich experiences where you can actually send data and interact with the websites. For example, Twitter, Facebook, Instagram. With Web 2, you will just create, say like with Twitter, if you want to send a tweet, you send a tweet, and that tweet goes to a centralized service owned by Twitter, where it gets redistributed amongst all of these databases and then represented to users. Web3 isn't that much different when it comes to building on the front end. The difference is you're not interacting with a centralized database. All of a sudden, you're using something called an RPC, remote procedure call, and that's an API that runs on a specific node in a decentralized network. The actual API interaction is pretty much the only difference in Web3. There are some user experience differences, but as far as a front-end developer goes, you can really abstract all that away, and the experience that you're building ends up being about the same as Web 2. I will talk about those differences, though. Some of the benefits in building Web3 is that it's all anonymous. I send money from A to B. I'm the only one that can prove that I am A. No one else knows that I'm A, so it's anonymous. It abstracts away that authentication layer. All of a sudden, you don't need things like username and password or email to be able to identify yourself. So that anonymity is pretty nice. And I can prove that I'm the one that is A. Cryptographically, I can prove that. And it's verifiable, meaning that there's without a doubt, I'm the person that is A. I don't have to trust Twitter to say that because Twitter really they'll be the ones that own any posts that I make. Whereas with decentralization in Web3, you're the one that really owns your data. So what tools do you need to build in Web3? Again, not that much different. The basic JavaScript, HTML, CSS is mostly pretty much what you need. You also need probably a front-end framework, React, Angular, Vue, Svelte, all of them will work. React probably has the most robust ecosystem surrounding Web3, so I would recommend it. But any front-end framework would work. And then you also have to think about what kind of environment you want to build for. You can build for any blockchain really in Web3, but EVMs are probably the largest audience. When you're building for an EVM, meaning an Ethereum virtual machine, you end up building for both the C chain, Ethereum, Polygon, LL2s. There are several different blockchains that run on an EVM. And that creates a standard API that you can interact with that is the same, and it gives you the widest audience when you're building. When you're building for MetaMask, for example, most of the time, you're going to be using an EVM. Some of the tools that you actually need to be able to interact with these RPCs in Web3, the big three, I would say, are window.ethereum. This is a global variable set by browser extension wallets like MetaMask or our upcoming Core wallet. Etherjs JS, Web3 JS. You can use one or the other, but they're both really powerful Web3 frameworks that create RPC providers that let you interact with the blockchain. And this is a big question. Blockchain data is all public, right? The data is decentralized across several nodes on the network, but how do you actually get that data? And the answer is, again, RPCs. RPCs are these APIs that actually live on a node in the network. When you interact with an RPC, you're getting data directly from the blockchain, which is really powerful. The problem with this is that RPCs are very low level. They give you data that is a very narrow snapshot of what the data looks like on the blockchain. I can get transaction details. I can get those details by providing a transaction hash, and it gives me some of those details. But the data isn't formatted in a way that's easy to consume on a front-end project. And if I want to look at any sort of aggregate data, for example, if I want to look at the gas price of transactions over a period of time, you can't get that from an RPC. So the solution to that is to use an index database. What you need to do is you need to put all this in an API, go through the blockchain block by block, and process that data in a way that lets you aggregate the data over time. You're bringing Web 2 to Web 3. There are some popular solutions to this. The Graph is one of them, and it's basically just a GraphQL API. It's an indexing service that indexes the blockchain and then gives you a Web 2-based API in GraphQL that lets you query data on the blockchain. And using tools like that are really powerful. So window.ethereum, this is a global variable set in JavaScript that will run in all browsers that are connected with a browser extension wallet. It's set by browser extensions such as MetaMask. And what this is it allows you to, one, check the status of your wallet, and that is what chain is selected, what address is currently selected in the wallet. It lets you listen to changes and interact with the wallet in that way. And building around these browser extension wallets is one of the core principles when it comes to building a Web3. When you're building a website, really, you have to interact with these browser extension wallets. That's how you interact with the chain. If you want to send a transaction, you have to click that approve button in MetaMask. So using this window.ethereum is going to be an essential piece of building a Web3 on the front end. You also can use this object to interact with the RPC, these APIs on the nodes. You can use it to send transactions, to sign, and all of these methods are based off of standards called EIP, Ethereum Improvement Proposals. And that means that they're going to be the same methods that you're going to use across all EVM blockchains. This is what an RPC request looks like using the window.ethereum object. Here, we're just sending a request. ETH chain ID, that gives me the chain ID that is currently selected in the wallet. The response looks something like this, which the result you'll see is 0xD2AF, a bit of nonsense. You're going to end up dealing with, this is hex. You're going to end up dealing with a lot of weirdly formatted data when you're actually using RPCs. You have to do a lot of parsing. Here you can just use parseInt with a base 16 to turn that into an integer, 53935. That's the chain ID for DFK chain, one of our new subnets. But basically, yeah, it's, the data that you get is very low level, not exactly optimized for the front end, but that's how you use it with window.ethereum. Etherjs Js and Web3 Js, these are two different RPC providers. They're JavaScript libraries. They don't have to run on the front end. You can use them on the front end. You can use them in an API, but what they are is RPC providers that give you additional formatting, additional methods that you can use to interact with the RPCs. For example, here's an example. Here I'm using Etherjs Js just to create an RPC provider. And a provider, I should tell you what this is. It's a wrapper around the RPC URLs that gives you all these methods that you can use to interact with the blockchain and the RPC in that way. So here, I'm using the Etherjs provider to just get transaction details. Again, the data that we're getting is pretty low level. All the numbers that we have here, gas price, these are all the details, all the data that you might be working with if you're trying to query a transaction. All of them are in hex. Actually, they're in big number. Dealing with big numbers is something else that you're going to have to do when you're building on the front end for Web3 because of JavaScript precision issues when working with larger numbers. But the details aren't exactly optimized, and it's not really clear what the data that you're getting is. But this is how you do it on the front end, if you do want to query the RPC exactly. So I mentioned this imprecision in JavaScript when dealing with numbers. We're all building financial applications. That's what most of the apps that we're building using Web3 on the front end are. When you're building in finance, you really need numbers to be precise. If I go, here's an example in JavaScript where numbers can't be precise using vanilla JavaScript. If I were to take 2.55 and add that to 0 over and over, or well, add it to itself 100,000 times, I would expect the output to be 255,000, but it's not. 254,999.99 repeating. This is because JavaScript cannot mathematically exactly, precisely represent certain numbers in vanilla. So you can't do it with vanilla JavaScript. That's why you need to use big number libraries. Etherjs uses one called BN. Here's another one that I love to use called big.js. It's a really popular option. But you can do the same thing, just add the same numbers over and over, and you get the proper output. There are a few different libraries that you can do this with. Big.js, again, my favorite. But they all have pros and cons. Big.js is really good because it has floating point support, meaning that I can give it any sort of decimal, and it'll give me an output that will match that decimal place. Whereas BN.js and a lot of the other options don't have floating point support. If I want to store the number 2.55 as a big number, if I do it in Big.js, I could store an object, create an object for a big that will easily be turned back into 2.55. If I want to do it in BN.js, then I need to store 255, and then as a separate variable, store the number 2, which tells me how many decimal places I need to move in order to be able to turn that back into 2.55. So I could turn 255 back into 2.55. That makes using a lot of these big number libraries that don't support floating point pretty difficult. But that's one of the reasons I like Big.js. Big.js does not have support for hex. A lot of the data that you're going to get from the RPCs is in hex formatting, so it's another con. But usually when you're using hex, you only have to convert it to a decimal one time, and then you can just use Big.js and use that everywhere else in your app, which makes it pretty easy to work with. Honorable mention goes to JS bigints. Do you guys know what these are? Native JavaScript bigints. They're pretty new, but basically it's native support for big integers in JavaScript. It's a solution that is native to JavaScript for all these big integer issues. There's support for across most browsers except for IE, Internet Explorer. But the real benefit of this is it's agnostic. So if you ever are building a library for Web3, I recommend using it. It's newer. Etherjs does not use it because Etherjs was built before bigints became a thing. But if you want to build an agnostic solution using native bigints is really good. A couple of other tools that you're going to need when interacting with RPCs. One of the problems that you'll run into pretty often is if you want to say query a list of balances for, say I have a list of tokens that are owned by a wallet, and I want to get what is the balance for each of these tokens? I want to build a portfolio, basically, for a wallet address. With RPCs, you need to do that in several different calls. So if I have 50 token addresses, I need to make 50 calls to the blockchain to do that. You can use something called a Json batch provider. What this does is it batches all these calls into one, and it lets you do it in a single call. Or you can use a special smart contract called multi-call. Multi-call is a smart contract that you can deploy to any EVM blockchain that lets you call an unlimited number of RPCs and aggregate that into a single call. So you only have to do one round trip to the RPC, one round trip to the blockchain. It's super performant. And when you're doing something like batching, there's a 40 call limit to batching with RPC batch provider. So if I want to query 80 calls, then that means I need to do 2 separate calls and then aggregate the data between them, which is a little bit messy. With multi-call, you don't need to do that because you can do an unlimited number of calls. So it's really easy to use. I would definitely check it out. Not a lot of people know about that one. I just found out about it like a few weeks ago. The last thing I want to touch on is how to scale your front-end team for Web3. So Web3 is, again, not that different from Web2. The biggest difference is these RPCs. RPCs are the only thing that's different, really, between Web3 and Web2 development, aside from developing around a browser extension experience. But when you're building in Web3, you really can shove all of that RPC logic into a box, put it in the corner, put it in one place in your application, and that's it. Really, ideally, you shouldn't need to touch the RPCs in the front end at all. The best way to do it is to build off of an index database. RPCs aren't that powerful when it comes to querying the blockchain. You can only get a narrow snapshot. You can only query one thing at a time and get a very narrow view of the data on the chain. So really the best way to do it is to index. Again, go block by block. Create a separate database. Go block by block, transaction by transaction, and create aggregate data sets that you can use using the graph or some sort of API or anything. That way your front end can use Web2 to interact with Web3. Put the Web3 in the very back of your application away from all of your front end development, and you'll be able to build your products a lot more quickly and scale a lot more quickly. It also makes it so when you're hiring, I get asked the question a lot about how you actually hire for Web3 because it's difficult enough to hire front-end developers, and finding front-end developers that also know Web3 is pretty rare. But really, the best way to do it is to not even worry about Web3 on the front end at all. Just build for Web2 and put all the Web3 stuff in an API and an index database on the back end. And that's it. Does anyone have any questions? Yeah. Sure.
So we are bringing an application where we have a huge discussion whether to just go directly from one end to the RPC or go with the graph and have a strong end to the graph. The problem is if you have users, like if you want to give them easy transactions and then pay for the transactions, especially now we have users who are not tech users. So the real world problem, or this is a real world problem, the real world user. We have to already walk towards like Web3 blockchain, and then on top of it, tell them like, yeah, you can pay for your like QEs with the graph open, and then you can bridge over. That starts to become very complicated. And do you have like a solution where, for example, something like if you use the graph, it's just invisible to the users, and for example, the data is going to finance it or something like that. I don't know.
With interacting with blockchain, or is this for just getting data?
Just getting data, showing them the data. That's it. And just to show the data, if you use RPC, that's free because RPC was, on a cost basis. But if I query through the graph, I have to pay to the GIP. And that cost has to go with either I have to sacrifice some centralization and say, okay, I'm going to build a centralized call provider. I'm paying for the calls from my users, but that means I'm listening for the failure. If my service goes down or my service goes down, all the users.
So you're talking about sacrificing decentralization, basically. If using that for like
or even push the response to the users, which is not a very good experience.
Yeah, I mean, so the question is, how do you make that decision on whether or not you should have the Web3 logic on the front end, or when you're using a decentralized database, indexed database on an API somewhere, you run some risks, it becomes centralized, which is really Web2, and you end up having to pay server fees and all of that. And is that right, the question? Okay. Well, we can talk after if I don't fully understand. But really, the issue is that when you're dealing with RPCs directly on the front end, the data that you're getting isn't exactly formatted in the way that you need on the front end. Front ends need to be dumb. Like, very dumb front ends are very performant front ends. They're front ends that you can scale quickly. And when you're working with RPCs directly on the front end, it becomes very difficult all of a sudden to create simple front end apps that don't have to worry about that stuff. So putting on an API, you are going to sacrifice decentralization, but it makes it a lot easier to build apps quickly. And ultimately, it is still decentralized. You're just creating an abstracted layer around it. I hope that answers your question. If not, then let's talk a little bit more after. Yeah, I guess there's pros and cons. It's just very difficult to scale when you have RPCs all over in the front-end code. Yeah, go ahead.
Do you have any recommendations or resources for Web3 UI components or customers that you use? There's WebMe, SH,
Yep.
Web3 UI, and maybe also on the design UI UX side, you have some resources where you get inspired on how good looking UI UX feels.
So the question is about the user interface and how do we get inspired to create good-looking Web3 user interfaces and And what else was the question?
Yeah, kind of like what are your resources?
And what are some of the sources? Yeah, what are some of the tools for using React with hooks and whatnot? Well, there's a Web3 hooks library too, so that's specific for React. That's really useful. I would recommend looking into that. All of these tools that I've mentioned can also be used in Angular, Vue, any other front-end framework. They're not necessarily specific to React. When it comes to building a UI around it, you really just need to convey trust to your users, be able to update your data quickly, because a lot of chains like Avalanche, with 5-second finality, or less than that, sub-second finality sometimes, you need to be able to pull the RPCs, pull the API frequently to get that data. But otherwise, it's pretty much all the same as Web 2. You can use Material UI, Tailwind, any sort of CSS framework, build good-looking components, and just build a UI around that. It doesn't necessarily have to be a Web3 UI. It's really all the same as Web 2 on the front end. The only difference is in the data logic. Does that make sense? Yeah. Aaron.
Are there any providers where, I don't know exactly how the map works, but is there anything where you can just kind of like send in, here, use these calls, and time this contract commits an event, and it'll automatically do the indexing for you and potentially decentralize that? Like every transaction that it submits an event, usually that's something that you might want to index, and using Web3 application, is there any provider that does something like that?
There are observable providers. All of this is running, so when you're indexing on the blockchain, so the question is there any way to listen for events on the chain that let you index? Is that right?
Basically, it's like contracts submit events. That's usually the type of stuff that you want to index. Are there any third-party libraries that allow you to do that, to create application-specific things on other core applications, to create the indices you want when you're actually building the front end for a Web3 application?
This is a good question. I'm not actually the one that's building any sort of indexing service. So I don't really know the answer, but I can look into it. I know that there are observable patterns that you can use around RPCs. There are also WebSocket-based RPCs that you can use that do emit events, but I'm not sure exactly if there's any sort of standardization around those events.
If I can answer, I have used something called Etherjs Defender, or they have a tool suite where you can put in the contract address, put in the functions you want to listen to, or then put in conditions on what function, and then make an automated stack which will guide. Once that trigger is wired, it will fine. Yeah.
So I had the same problem, and it's very recent. It's called OpenZeppelin Defender or something like that. You can put in the contract address, and you can put in the functions. The contract has to be verified. That's one condition. And you can put in the functions, and it will listen to that function call or that event emitted from that function. And then based on when that gets fired, and if you can put in something like after two block information, or one block information, once that happens, that condition is met, you can put in another script that when A happens, then do B, if that was your question.
Yeah.
Thanks. What was your name? Ramesh. Nice to meet you. Thanks. Anyways, I think, how are we on time? I think we're pretty good if anyone has any other questions. Otherwise, we can wrap it up. Thanks so much.